Hi, everyone. My name is Devang Aggarwal, and I'm joined by Jhinuk Barman. And we are going to be presenting our final project for CS598, Deep Learning for Healthcare. And the paper that we reproduced is Convolutional Neural Networks to Predict ICD-9 Codes of Medical Records. So the main point of this presentation is going to consist of the summary of the original paper, and then we're going to talk about how we reproduced the paper, where we're going to talk about data preprocessing, the models we used, and the results. So summary of the original paper. So basically in this paper, they propose a deep learning algorithm to classify disease types and identify diagnostic codes by using only subjective components of progress notes and medical records. And then they applied standard text processing procedures to parse the sentences and word embedding techniques for vector representations. And then they built a CNN model on the medical records to predict the ICD-9 codes. So the data pre-processing, how we did it, right? So we used the data set from MIC3, and basically we cleaned the data using Panda SQL, and we basically created one holistic filter data frame that holds certain key data. And then we embedded this data using the glove embedding. And then we split the data up into the train, validation, and test directories. And basically it was a 60-20-20 ratio split. So the models we used is basically we used the model that they had actually used, which we reproduced, which is a CNN model. And then the new model that we've produced was the LSTM. And basically the ML libraries that we used are sklearn, TensorFlow, Keras, and NumPy. Now I'll hand the mic over to Jhinuk so she can go over the results.
So for the results, the original paper had a precision of 0.436, a recall of 0.409, and an accuracy of 0.409. From our table, you can see the training results of the CNN model. For us, we had an accuracy of 0.365, which is within 1% of the paper. And the precision and recall are both within the paper results as well. And at the bottom, we have the training results of the LSTM model. The accuracy is 0.233 within 2% of the paper, and the precision and recall are also both within the paper cutoffs. For the original paper, we were able to reproduce it using the MIC3 dataset. The CNN model layers and parameters were all clear, and the diagram was presented detailing the exact order of the layers and structure. In terms of what was difficult, the glove embedding was not available in the author's code, so we created our own pre-trained glove embedding file using the MIC3 dataset's note text as the corpus. Thank you.